Hi everyone. Today we're going to study geometrical meaning of the zeros of a polynomial. The zero of a polynomial p of x is the point where the graph y equals p of x intersects the x-axis. In general, given a polynomial p of x of degree n, the graph of y equals p of x intersects the x-axis at most n points. Therefore, a polynomial p of x of degree n has at most n zeros. Example 1. Find the zero of the linear polynomial 2x plus 3 and draw the graph y equals 2x plus 3. The linear polynomial 2x plus 3, we're going to equate to 0, then solve for x. So we write 2x plus 3 here equals 0. Trying to solve for x, let us isolate the x here. The positive 3 we transpose to the right, it becomes negative 3. Then we divide this equation by 2. The value of x equals negative 3 over 2. This is the zero of this linear polynomial. Now, let us graph our line, y equals 2x plus 3. We know that the graph of y equals ax plus b is a straight line. To graph this line, we're going to put some values for x, and eventually, we will get the value for the y. Suppose we assign x equals negative 2. The value of y will be negative 1. Suppose x is positive 2, the value of y is 7. We simply substitute the value of x respectively to our function or the graph, and then we will get the value of y. Let us plot the 2 points and connect these points. So this is now the graph of this function, y equals 2x plus 3. We can see that it is a line. Observing the graph, we can see that the graph intersects the x-axis at the point negative 3 over 2, 0. Thus, the zero of the polynomial 2x plus 3 is the x-coordinate of the point where the graph of y equals 2x plus 3 intersects the x-axis. Remarks: in general, for a linear polynomial ax plus b, a here is not equal to 0. The graph of y equals ax plus b is a straight line, which intersects the x-axis at exactly one point, namely the negative b over a, 0. Therefore, the linear polynomial ax plus b and this a not equal to 0 has exactly 1, 0, namely the x-coordinate of the point where the graph of y equals ax plus b intersects the x-axis. Example 2. Find the zeros of the quadratic polynomial x squared minus 3x minus 4. Let us equate to 0 and solve for x. We write our polynomial down here, and then this is equal to 0. Next, let us solve for x. We can do this by factoring. The factors of x squared minus 3x minus 4 are x minus 4 times x plus 1, both equal to 0. We equate each factor to 0 and solve for x. The first factor, x minus 4 equals 0, and the second factor, x plus 1 equals 0. Then we can solve for x. We transpose the negative 4 to the right. The first value of x equals 4. In the second equation, the positive 1 we transpose to the right. The second value of x equals negative 1. These are the zeros of the polynomial. Let us show the graph of y equals x squared minus 3x minus 4. When doing this, we can show some values of x and eventually we can see the value of y. Here are corresponding values. Let us now plot the corresponding points and we connect them by a smooth curve. So the graph is here. Please observe that the graph touches the x-axis at the point 4, 0, it's here, and negative 1, 0. Thus, the zeros of the quadratic polynomial x squared minus 3x minus 4 are x coordinates of the points where the graph of y equals x squared minus 3x minus 4 intersects the x-axis. We have these remarks. For any quadratic polynomial, ax squared plus bx plus c, the a here not equal to 0. The graph of the corresponding equation y equals ax squared plus bx plus c has one of the two shapes, either open upwards like this or open downwards like this, depending on whether a is more than 0 or a is less than 0. The a more than 0 means a is positive and the graph will look like this. The a less than 0 means a is negative and the graph will look like this. These curves are called parabolas. We have three cases for zeros of quadratic polynomial. Given a quadratic polynomial p of x, the graph y equals p of x intersects the x-axis at most 2 points. So we have the three cases. Case 1, when we have two zeros. Let's begin with this. For case 1 with two zeros, it means the parabola intersects the x-axis at 2 points. We have here two examples. This is our first example. This parabola opens downward. We can see that the graph intersects the x-axis at 2 points. Here is another example. The parabola opens upward. We can see that the graph intersects the x-axis at 2 points. Next, case 2, when we have 1, 0. This means parabola intersects the x-axis at 1 point. Then let us show some examples. We have here two examples. In our first example, the parabola opens downward. The maximum point of this parabola intersects the x-axis, so it is only at 1 point. In our second example, the lowest point of the graph intersects the x-axis. That is why it intersects at only 1 point. Now case 3, when we have no 0, it means the parabola does not intersect the x-axis. We have here two examples. In our first example, the parabola opens upward. This parabola is located above the x-axis, so it does not intersect the x-axis. The second example is a parabola that opens downward, but it is located below the x-axis. That is why it does not intersect the x-axis. Example 3. Find the zeros of the cubic polynomial x cubed minus 4x. Let us equate this polynomial to 0 and solve for x. So we have this x cubed minus 4x equals 0. Let us do factoring. First, we factor out the common factor, which is x. We have here x times x squared minus 4 equals 0. But this x squared minus 4 is still factorable into x minus 2 times x plus 2. From here, we can see that we have three factors. Then we're going to equate each factor to 0 and solve for x. The first factor, x, equals 0. Second factor, x minus 2, equals 0. Third factor, x plus 2, equals 0. The first value of x is already 0. For the second value, we look at the second equation. We solve for x. This negative 2, we transpose to the right, so we have the value of x equals 2. In the third equation, x plus 2 equals 0. Solving for x, we transpose positive 2 to the right. So we have x equals negative 2. Here are the three values of x. These are the zeros of the cubic polynomial. Let us show the graph of y equals x cubed minus 4x. First, let us assign some values for x, then solve for y. Here are the corresponding coordinates. Let us plot these coordinates and connect them with a smooth curve. The graph will look like this. The graph intersects the x-axis at 3 points, namely when x equals 2, when x equals 0, when x equals negative 2. Thus, the zeros of the cubic polynomial x cubed minus 4x are x-coordinates of the points where the graph of y equals x cubed minus 4x intersects the x-axis. Example 4. Given the graph below, what are the zeros of the polynomial? We can see that the graph intersects the x-axis at the points 0, 0, the origin, and 1, 0. By definition, the zeros of polynomial p of x are the x-coordinates of the points where the graph y equals p of x intersects the x-axis. Thus, the zeros of the polynomial are 0 and 1.